Okay, now we're going to look at actually finding all of this information I've been talking about and also doing the graphs. So as it says, to find all information to graph and determine domain and range. So we'll figure out domain and range last. But when you're asked to find all information, as I go through this example, of course, I'll be labeling each thing that I find. So when you go to do your homework, then I want you to find exactly the same information. Okay, so first of all, on this one, I'm going to start out by getting y on one side by itself. So I would have y is equal to x minus 1 squared plus 3. All right, first of all, I want to know what the value of a is. Now, looking back at your notes, your a, let me slide it back up here. See, this is the form we're looking at. So a is going to be the number that's multiplied in front of your parentheses, which on this one would have to be an understood 1. Now your a value, remember, tells you whether your graph opens up or opens down. And since this is positive, that tells you that your graph opens up. Okay, next let's find our vertex. Now this is in the standard form where you can just look at it and tell what your vertex is going to be. Don't forget to change the sign of H. So where this is identified as a -1, you would have +1 down here, have +3, so keep that the same. All right, then I want you to find the x and y intercepts. Okay, so let's work on the x-intercept first. Now the note that I had given you, I said to set your function equal to 0. So in other words, if I'm setting my function, this is my function, equal to 0, that means I'm substituting 0 in for y. All right, so now I've got to take this equation and solve it. Okay, so first thing that I would do would be to subtract the 3. And then you're going to use your square root property and take square root of both sides, which here you would be left with x minus 1. But now you take the square root of -3, you'll have plus or minus square root, well, plus or minus I square root 3. Now since that comes out to be imaginary, there's really not even need for you to go any further with this, because as you know, when you're graphing, you do not have imaginary values on your graph. So as far as an x-intercept, you have none. Okay, y-intercept. Okay, so the note that I gave you for that was to substitute 0 in for x. Okay, so if I solve this, of course, 0 minus 1 is -1, but you square -1, you get +1. So 1 plus 3 gives you 4. So that would be the point 0, 4. Okay, I also want you to identify the axis of symmetry. Okay, that was always a vertical line. So I said always do x equal, but it's always equal to the x coordinate of the vertex, because the axis of symmetry always goes through the vertex, so that would be equal to 1. All right, now taking this information and graphing this. Okay, so first of all, what we're going to do is plot the 2 points that we have, which is the vertex and the y-intercept. So my vertex is at 1, 3. And my y-intercept is at 4. Now I also want you to dot in the axis of symmetry. So the axis of symmetry was x equal 1, so it's the vertical line that goes through the vertex. Now, when you're graphing a parabola, typically you want, of course you want the vertex, but then you want a point on each side of your axis of symmetry. So remember what I said about axis symmetry, that means the left and the right hand side are mirror images of each other. So what you can do is take this point and reflect it over here. So since there's 1 unit between the point and the axis of symmetry, then just go 1 unit on the other side, reflect that point. We did say that it opens up. So based on how these points are, then, I mean, there's no other way to connect them up except for your graph to turn up. So there's your graph. So now that you've gotten it graphed, it makes good sense as to why over here we determined that there were not any x-intercepts, because your vertex sits above the x-axis and then it turns up from there. All right, domain and range. Let's identify that real quick. So if you remember, domain is your x values. So if you look at this graph in reference to your x-axis, just like before, I'd ask you, does it go to the left forever? Yes. As this side goes up, it gradually is widening to the left. Does it go to the right forever? Yes. As this side goes up, it gradually widens to the right. So your domain is negative infinity to positive infinity. And then range, of course, is your y values. So you look at it from your bottom to the top of it. Now, this graph does not go down forever. If you start looking from bottom to top, the first y value that's used by your graph is here at positive 3. So you would include the 3, and then it does go up forever from there. Okay, our next problem. Okay, this is going to be the same form. Now, it is written in a little bit different order. If you wanted to rewrite it, you could. So to make it look like the form we just finished, if you chose to turn it around, would be this. Okay, so that way it's more in the order of what we saw. All right, so let's start with A. Okay, remember A is the number in front of the parentheses being multiplied, which here is a -1. So since this is negative, that tells me that this graph opens down. Okay, then from there, let's talk about the vertex. Okay, so from inside is where H comes from, but you change the sign, so that makes that positive 3. And then your y coordinate would be the positive 1. Okay, from there, let's do the x-intercept. Okay, so we set our function equal to 0. Alright, so going about solving this, the first thing that I want to do is subtract my 1. But then I have to divide by -1 because I have this negative in front. So now I actually will have equal to positive 1. So now I take square root of both sides. Now square root of 1 is just 1, but don't forget your plus minus. And then to get x by itself, you would add the 3. Okay, so calculate your plus and your minus here, so you actually end up with 4 and 2. So that means that we have an x-intercept at 4, 0 and an x-intercept at 2, 0. Okay, now our y-intercept. So this time we're going to substitute our 0 in for our x. Okay, so 0 minus 3 is -3, but -3 squared is 9, but then you've got the negative in the front, which gives you -9. Of course, plus 1 is -8, so our y-intercept is at 0, -8. And then our axis of symmetry is a vertical line, and again it goes through the vertex, so it would have to be x equal 3. Alright, so using this information to graph it, okay, so your y-intercept is at -8. Okay, so we'll plot that point. Your vertex is at 3, 1. Okay, axis of symmetry goes through your vertex. Let's see, we also have our x-intercepts. So I have a x-intercept at 4 and an x-intercept at 2. Now, I did say we only had to have 3 points, you know, the vertex and one on each side. But since I have this one down here, whoops, about off the screen, sorry. But since I do have this one down here, I'm going to take and reflect it. Now this time the distance from here to here is a distance of 3. So make sure you count your distance. And of course you can tell from your points, your parabola does turn down. Okay, so last again real quick is domain and range. So if you ask yourself those same questions, does it go to the left forever? Does it go to the right forever? It does. Because as each side goes down, it's going to continue to widen, so that includes your left and your right. Now, your range this time, when you're talking about from bottom to top, it does go down forever, so your range, you're going to have to start off with negative infinity. But it doesn't go any higher than this value, which the y value at that point is positive 1, which is included, so you'd have your bracket. Okay, so there's that problem. Alright, the other one we're going to graph is going to be one that's in the other form that we haven't looked at yet. And that is just an X. It's just something got messed up whenever it printed. Now, if you want to put this in the correct order, you know, because you're used to having x squared first, if you wanted to turn it around and have negative x squared minus 4x plus 5, then you definitely can do that. Okay, my a value would be negative 1. When it's in this form, your a is the coefficient of the x squared. So that's going to be negative 1. So since it's negative, it's going to open down. Okay, now vertex. Now, with this one, you have a little bit more work that you have to do with your vertex. Remember, you've got your formula of negative b divided by 2a. Alright, so my b value is negative 4, so I have negative 4 divided by 2 times a, which we've already said a is negative 1. So that's going to give us a positive 4 divided by negative 2, which is negative 2. Now you have to substitute this back into the problem to find your y value. Okay, so be careful with your signs here though. You square the negative 2, you get 4, but then this does give you a negative 4. Of course, that's a positive 8, and then you've got your plus 5. So that's going to be 9. So your vertex is located at negative 2, 9. Okay, x-intercept. Okay, so this is where we set it equal to 0. Okay, now you need to solve this, which you can do by factoring, but what I would suggest you do, especially if you've turned this around, is to factor out a negative 1. Okay, and then factor, so you'll have x squared is x times x. Of course, 5 is 5 times 1, and you would need a plus 5 minus 1, so you get x equal negative 5, x equal positive 1, so you have the point negative 5, 0, and the point 1, 0. So, like in this case, the negative 1 you pulled out, don't worry about that. Okay, your y-intercept. Of course, if you substitute 0 in for x, of course that's 0, so therefore you're just left with 5. So that's the 0.05. Now, when it comes to graphing, you do everything the same way as we were doing a while ago. As I told you earlier, the big difference is with your vertex when you're working with this particular form. Alright, so let's plot our points. Okay, so my y-intercept is at 5. I have an x-intercept at -5 and at +1. My vertex is at 2, 9. -2, 9. I knew that wasn't going to be right. All right, let's see. 5, 6, 7, 8, 9. -2, 9. All right, we'll have to squeeze this in here. Okay, so again, if you wanted to reflect this other point, you could. This one, if you wanted to reflect it, there's 2 units in here, so that point would end up being here. So it does open down, as we said that it would. Alright, so real quick, domain and range. Okay, so if you notice, your domain each time has been negative infinity to positive infinity, and it always will, because one thing that I have already taught you and we've talked about is the domain of a polynomial function is always negative infinity to positive infinity. Okay, now your range, so it goes down forever, so that would be negative infinity, and of course it tops out here at the 9.